So I want to talk about this device today. So this is an open radio station, and I think we made it a carrier-grade hardware. So we will see more about this. So first of all, a small background on RapidSpace. We are co-founded by Nexedy and Amarisoft. Nexedy is an open source software editor, leading European one. And Amarisoft is the inventor of 5G vRAN, so they are writing proprietary software for radio, 4G, and 5G. So the goal of RapidSpace is to provide fully open edge cloud. And among the products we have, there is this open radio station. So I'll talk briefly about it and what it does, and then we will go deeper into hardware and then the software part, because, of course, to run it, we need to run software. And at the end, I'll talk a bit about the roadmap and what is making the ORS carrier-grade level. I hope I will have time to take questions at the end. So, open radio station. Basically, this is a all-in-one automated 4G and 5G base station. So this is totally autonomous. It runs both the E0B or G0B and the core network. So you can deploy this device in the field with no internet connection, then you have still 4G or 5G coverage. It has so everything inside, plus additional optional services run by SlapOS. We are currently supporting many bands, and we are adding the support for more and more bands. So first, RapidSpace was a software company, and we needed to provide some hardware because, of course, radio software needs to run on hardware. So our standard flow is actually to provide the source files to a partner that will manufacture the device, and we will buy the hardware, let's say, without software, totally naked. We will add the software, the licenses, and then we do the selling to the final client. In some countries, you need to buy telecommunication equipment directly on a local manufacturer. So in this case, the manufacturer will sell to the final client, and then the partner will buy the licenses from RapidSpace. Actually, being open hardware is really helpful in this regard, because we can give the source files and everything the partner needs to manufacture the device. It is really easy. So inside the box, there are two main parts. On the bottom part, there is a PCB for software-defined radio. So this PCB is really the open source part. On this PCB, you will find the digital to analog transceiver. So for now, we are using analog device chip. You will find the power amplification, the filters. There is also GPS input for time synchronization. And this PCB is also taking care of the power supply. So the device is now powered by PoE. So this is very convenient. So with just one network cable, you bring the power and the network. So this is really handy for deployments in the field. So this PCB is really the custom part that we are designing at RapidSpace. And on the top side, there is just a very standard single board computer. So we buy this from several suppliers, and on this computer, we run the software. So software is comprised of SlapOS, which is doing the deployment of the service, the monitoring, the configuration. Amarisoft, which is really the radio part, the radio software part. And Resist, which is our mesh network in IPv6 and taking care of the backhaul network. The communication between the two parts is done through PCI Express. Just one line of PCI Express. So we'll see more later about this. Regarding the software running on it, so I mentioned the 3 mandatory components, which are SlapOS, Resist, Amarisoft, and then above this, we have many options to run software, to provide push-to-talk, to provide instant messaging app, even industrial protocols like OPC UA, and CDN. So this is all for the client to decide what will run in this device. But here the concept is really cloud, edge cloud services, because you can't be more at the edge than on the radio station itself. You are directly interfacing with the clients. And the only bits which are proprietary are Amarisoft softwares. So what does ORS do? Basically, we are selling this device for 3 types of situations. So first of all, tactical situations for public forces. So I'll show you a small video about the ORS for police forces.
ORS, Open Radio Station, for private security networks. A lightweight autonomous base station for private 4G and 5G, MCPTT, video streaming in tactical edge. With 4G and 5G networks available everywhere. Police forces have adopted instant messengers as their primary communication tool. They use WhatsApp, Line, Telegram, or WeChat to communicate and exchange pictures or documents about suspects, because those tools are very convenient to use and are available anytime and everywhere. But sometimes 4G and 5G is unavailable. In case of earthquake, in case of burning tower, in case of terrorist attack. In all those cases, the public 4G, 5G network is no longer available. Police forces can no longer use their favorite instant messaging, and also sometimes, in case of mass demonstration, there are too many people with their phones. The 4G or 5G network becomes too slow and unusable. This is where there is a need for 4G and 5G private networks for police and defense. With only 2.4 kilograms and 32 watts of electrical power. The Rapid Space Open Radio Station is a plug-and-play, autonomous, 4G or 5G network that can be deployed anywhere to compensate for the lack of public 4G and 5G network. The ORS is attached on a telescopic mast attached to the police car. As soon as police car arrives on site, the ORS is deployed at 5-meter high, providing a communication range of up to 10 kilometers. The ORS provides Delta Chat, instant messaging with a user interface very similar to WhatsApp. Police can chat, do instant messages, vocals, exchange pictures, or documents, or real-time video streaming between police forces with body cams. Arcos X67 smartphone can handle push-to-talk, 5G smartphone, Bluetooth earplug, body cam, or between ground forces and command post. With a satellite link or a radio link, police forces can communicate using Delta Chat at national level. And thanks to its strong encryption, Delta Chat can also be used for police forces staying at home on call. With the ORS, police forces can enjoy the benefits of modern 5G communication anywhere, anytime, even when public 5G operators are unavailable. With ORS, 5G always works.
Okay, so this is one of the use cases. And another one is, of course, private 5G or 4G networks. So more and more we have countries opening their license, I mean the radio frequency licenses for private networks. So people want to deploy the ORS for their own network. So I have also a small video of rural deployment. So, okay. So here we see the ORS in the field deployed to provide a 4G coverage where it was a white zone. And internet is provided through satellite communication. And just with one device, one antenna, you provide coverage for the whole area of the farm. Also, like I said, you can put open source industrial protocol in the ORS. So another use case is for industry, for providing coverage inside the factories, and even controlling the factory from the ORS. So here we show a small proof of concept machine that is doing selection of cherries. So we will see here the machine is sorting the cherries. So anyway, so with this flexible device, you can think of many use cases for its usage. So let's go deeper in the hardware part, the software-defined radio PCB. So first of all, the schematics are provided in PDF form. So we are still using Altium to develop this PCB because it was developed with Altium at the beginning when we bought the intellectual property. But we are releasing the Altium source files plus every output files in clear format, like PDF for schematics, the gerbers, the bill of material, so that the project is really usable even if you don't have Altium. In this quite old schematic, you see the transmission part, where when the take signal is amplified through 2 PAs in parallel. Nowadays we have four PAs in parallel. And it goes into the TDD switch because most of the open bands are in TDD. So we need to do a switching between emitting and receiving. So when we emit the signal is going through there in the bandpass filter and to the antenna. And when we are in receiving mode, the signal is going from the antenna, the bandpass filter, the switch, and then it is amplified with a small LNA. So we provide the schematics, and let's see. So the analog device chip, which is a transceiver, is really at the heart of the PCB. This is the one which will define the performances of our ORS. So for now, it supports only 40 megahertz bandwidth. This is because we are using this quite old AD chip with 2T, 2R channels and 40 megahertz bandwidth support. So this transceiver is controlled through FPGA. So the FPGA goal is to do the communication between the computer and the transceiver. So the FPGA is seen as a PCI Express endpoint, like I said, and the main usage is to send the samples, the digital RF samples, into the AD chip. So this is done through big DMA transfer, and this is eating the majority of the bandwidth. And then the FPGA is used to do all the glue with everything on the board. So I talked about GPS. So we have GPS for time synchronization. So you can select between GPS time or PPS, external PPS. The FPGA will talk with UART to the GPS itself to know its status. It will configure the clock cleaner module to have really good clocks without jitters. Talk to the flash to write and read its own firmware, and talk to the PCI connector. So the FPGA firmware has the same license as Amarisoft because it's used now with Amarisoft software. We could, of course, use this PCB with other open source radio software, and in this case, we would use an open firmware. About the transmission part, so the power amplification, it's really important to have the best signal possible and the most powerful signal. So having a powerful signal is not to support a bigger range, because the range is really, the radio range is limited by the power of the UEs, the ones that are talking to the radio station. But the power will help you have many UEs, because you will use a fraction of this power to talk to each UE. So nowadays, the PCB looks more like this, with 4 PAs in parallel. We also changed, compared to the previous schematic I showed you, the TDD switch is here, just before the antenna. And you see the filter is before the amplification. So it means the filters are really much more smaller than the previous ones. But we needed to add another filter for the reception part. So we have twice more filters, but they are much smaller. And also the filter itself is inserting a bit of loss. So by removing the filter, we have also more power with this design. And reception part. So this is really, the reception part is really what is defining the range of the radio unit. So the sensitivity on RX is determining how far the UEs will be able to talk to the ORS. The signal from the TDD switch is going on the other side of the PCB. And we see here a small LNA and then going directly to the analog device chip. So you see these long tracks for RX signals. We needed to make them shielded from the other parts of the board. So that's why we needed a customized case. So this is aluminum case, and you see that it matches perfectly the RX tracks, so that the RX tracks are enclosed in this tunnel, let's say. So it's shielded from the other RF devices, and it lets us have a good RX signal. Also, we are using this case for heat dissipation. You see, we can put thermal paste in the different parts. So, of course, mechanical design is also open source, and you need to build them together to have the final product. So this was about the hardware, but in order to run all of this, we need also software. So I'm talking briefly about the management system we are using. So all of this is done through SlapOS. SlapOS is a pre-existing software run for other cloud services, and we are reusing it for managing the ORS. So the architecture globally is a master node controlling all the compute nodes, and you are going through the master to configure any of your services. And this can run services in data centers, in the drones also, or in the ORS. So how we do the software in this Open Radio station. So first of all, we install Linux. So this is Ubuntu 20.04. So here we do manual installation. It was one of the very first ORS. Nowadays, we automated the Ubuntu installation, of course. So this is just a regular Ubuntu installation, and after Ubuntu will be installed, we will need to register the ORS to the SlapOS master in order for it to be able to be controlled. So, okay, that's it. You have for Ubuntu. So we are first asking a token on the panel. So this token is used by a playbook, Ansible playbook, and this playbook will do the registration of the compute node, in this case the SBC, into the SlapOS master. So once you run this playbook, then you will be able to see your server in the panel. So next thing to do is to supply the radio service. So here we see configuration of the service, so the power, the frequency you use, etc. So SlapOS also comes with CLI and API because some of our clients want to integrate it with their own OSS, BSS systems. So in this case, they will use SlapOS as a client. So I talked earlier about monitoring. So monitoring of the service is a big part of SlapOS. Of course, when the system is deployed on the field, you won't have immediate feedback through the panel. But when the system is able to talk with the master, you can monitor the service in real time through this monitoring application. So the important stuff is that SlapOS, like I said, was already designed, and you can run many services. You can also do the invoicing of your clients, because invoicing was already a feature of SlapOS, so we didn't need to reinvent the feature. And if you need special development about SlapOS, you can ask NextAD, who will do support for customization. And here on this video, we are trying to supply a CDN inside the ORS. So CDN is a custom service that you can supply, and then you have CDN directly on the ORS. So okay. Okay. So about the roadmap now. So what we will do in the future for the ORS. So we are targeting a band above the 5 gigahertz, so band 46. Because, of course, those bands were not used, so those are the ones that are open for private networks. So band 46 is very wide, like 800 megahertz, so we will select a narrower band to work on, because we won't work on the full band directly. We want to support 100 megahertz bandwidth, because for 5G there are some bands where you can run 100 megahertz. Of course, we will need to change the transceiver, and we will redesign everything around this new transceiver. Hopefully, we found a transceiver really close to the analog device one, so we will see how it goes. We want to do 2 times 10 watts. I'm not sure if I mentioned it, but right now it is 2 times 1 watt for the ORS. So that's why it's consuming only 32 watts of power. But for some situation, we need more power. And another thing is PTP via PTM, so it means precision time protocol. Right now, the only trustable source of clock synchronization is GPS. But when you run the ORS indoor, it's really not practical. And you want time synchronization from the network. So a goal is to give the time synchronization from the computer with PTP to the FPGA with PTM, which is a way to synchronize PCI Express endpoints. So I just put a picture of our current proof of concept for the 10-watt power amplification board. This is using RFHIC amplifier, but we needed to put MCU because it is really, we need to carefully prepare the voltage and everything to have the best amplification possible. And of course, with this kind of high power, we need also to have a feedback channel because we need to do pre-distortion. Otherwise, the signal won't be good enough. Of course, for the ORS, we can think about the ORS itself as a NUI, because if the ORS needs to get internet from somewhere, we could build the module inside it. So it could be a Starlink UI or a Wi-Fi point, so that you need only the ORS. Right now, if you want Wi-Fi going to the ORS, you need a small Wi-Fi adapter. We can support more frequencies and multiple frequencies together, because right now we are only doing 5G standalone, but in some cases we need to do 5G non-standalone, and in this case we need several frequencies. Maybe we'll do 44R, 88R in the future, or even more power. Of course, I wrote this here because our goal also is to help adoption of this open source hardware by other vendors. So we would be really glad to see other companies use our design for their own product. And of course, if an open source radio software wants to use our PCB for running its software, it would be also a really great opportunity. So I said at the beginning it is carrier grade level, and I think it is because in terms of performance, first, we are really matching all the expectations of the tier 1 telecom operators. We are already providing all the latest 3GPP features, because of course it's software defined. So as soon as a new 3GPP version is released, then we just need to upgrade Microsoft software, and that's it. So we tested also this small device with many different core networks from existing telecom operators' core networks. So from performance point of view, it is really what the real telecom operators are expecting. And this hardware, it is running SlapOS, which is agnostic about the hardware, so we can run the same software inside other materials, so much bigger one. So this is a real telecom operator BBU. So you run the software in this BBU, and you connect the BBU to a radio unit. So basically, those two devices together are the same stuff as what we have in the ORS. But it is much more powerful and usable by telecom operators. So the same software run on real telecom operator. So you really have the same features on a very small device like this and a very big device like this. And we delivered a paper for telecom operators to go from the previous world of hardware material for radio telecommunications into software-defined radio. So this is a real big step to do for telecom operators, and we are trying to help them move to software-defined radio. So this is the end. Here you will find links about what I talked about today. We are releasing more and more stuff, and for example, the mechanical drawings will be released soon. Yeah, that's it. So now I can take questions. I'm not sure if I have much more time, but